We propose SemGes, a novel two-stage architecture that aims to generate semantics-aware gestures driven by fused speech audio, text-based semantics, and speaker identity. Existing methods struggle to generate semantically rich gestures, often producing repetitive, generic motions that lack discourse-level meaning and exhibit noticeable jitter. Here are some examples.
All right. I would like to choose a job that can provide me with a high sense of individual satisfaction. First, I believe that success is a process rather than a result of receiving plenty of money. All right. I would like to choose a job that can provide me with a high sense of individual satisfaction. First, I believe that success is a process rather than a result of receiving plenty of money.
In contrast, our model, SemGes, enhances gesture generation by leveraging a two-stage approach, ensuring gestures align both locally and globally with speech semantics.
All right. I would like to choose a job that can provide me with a high sense of individual satisfaction. First, I believe that success is a process rather than a result of receiving plenty of money.
Of our approach. In stage 1, we build a motion prior for holistic gestures, capturing both body and hand movements. We achieve this by training a vector quantized variational autoencoder, or VQVAE, to learn an efficient and compositional latent motion space. These codebooks allow us to reconstruct naturalistic gestures while reusing meaningful gesture components. In stage 2, we integrate audio, text-based semantics, and speaker identity to produce gestures that are both contextually relevant at the discourse level and fine-grained at the local level. By leveraging a semantic coherence module, our model ensures that text and motion prior embeddings are aligned. Furthermore, a multimodal consistency loss synchronizes the quantized multimodal representations with the learned motion features from stage 1, enabling the generation of semantics-aware gestures that maintain coherence with speech. Additionally, a semantic relevance loss selectively emphasizes key representational gestures, such as iconic and metaphoric movements, ensuring a more expressive and meaningful gesture generation process.
Personal satisfaction can boost my interest and passion to continue the job. For example, I love music, and in my free time,
Here's the model detail. First, we have global semantic coherence. This pathway ensures that our gesture and text encoders are well aligned by minimizing latent discrepancies between them. In simpler terms, it helps the model maintain consistency between what is being said and how it is expressed through gestures. Next, we have multimodal quantization learning. Here, we integrate multimodal representations and align them with quantized motion. These representations are then decoded into natural hand and body movements, making the gestures more fluid and expressive. Lastly, we focus on semantic relevance learning. This step is crucial because it emphasizes generating gestures that are not only natural but also semantically meaningful, ensuring that the movements match the content of the speech. Finally, we introduce a simple yet effective long sequence inference strategy. This technique smoothly combines overlapping motion clips, enabling gesture generation for extended durations without discontinuities.
money and reputation are things that I would like to come as a result of my recess. So a personal sense of satisfaction would let me enjoy the process. Secondly, a high personal satisfaction can boost my interest and passion to continue the job. For example, I love music, and in my free time,
We evaluate our model using two datasets, namely the Beat and TED expressive datasets. We compare our model with four baseline state-of-the-art models, demonstrating that our approach surpasses existing state-of-the-art methods in both objective metrics, such as FGD, and subjective user evaluations. The quantitative results show that our method, SemGes, achieves the lowest FGD on both datasets, indicating robust alignment of generated gestures with the ground truth. Additionally, it achieves the highest diversity score, demonstrating a variety of gestures and reducing repetitive patterns. Our method also maintains balanced beat consistency and achieves a higher SRGR on the beat dataset. The subjective evaluation further validates these improvements, as users rated our model significantly higher than baseline models, such as chi-MN and diff-CHG, in terms of naturalness, diversity, and alignment with speech content and timing. The statistical significance markers confirm that our model produces more realistic, diverse, and contextually appropriate gestures than prior approaches.